بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. النهارده ان شاء الله هنتكلم على o10 which talk about the colligative properties of solution. The colligative properties of the solution هي solution property depend on amount of solute which dissolve in solvent. طيب البروبرتيز دي ايه؟ هنلاقي حاجة اسمها الفيبر بريشر، هنلاقي حاجة اسمها elevation boiling point depression of freezing point osmotic pressure. But before talking about these properties, we must return back to the solubility chart. بسم الله. Okay, from the solubility chart, it illustrated that when having a different salts solubility chart, From the solubility chart, we can determine that when have a different salts may be soluble in the water and the other insoluble in the water. It's very important to write the ionic equations, and else it is very important to determine the solubility of each salt or each salt in the water. As an example, you will find for the fluorine salts, since the salt depend on the anion. So the anion of the fluorine, all of them are usually soluble in the water except the magnesium fluoride, calcium fluoride, strontium fluoride, barium fluoride, manganese fluoride, and lead fluoride. And we will find sometimes slightly soluble in the water, like the aluminum fluoride. Another time, we'll find all the nitrate salts are soluble in the water. Acetate salts are soluble in the water. We'll find for the radicals, all the hydroxide salts are insoluble in the water except the sodium, potassium, and barium, and some slightly soluble in the water like the calcium and the strontium hydroxide. They are slightly soluble in the water. It's very important to determine the solubility of the salts. One from the note, the ammonium ion in H4 is not the element, but it is the polyprotic cation, which also form the salts like the normal metal cations. And the ammonium salts, most of them are soluble in the water. Okay. Return back to the first property. The vapor pressure. If we bring it in a closed container, and start to boil it, firstly we observe that when we put the amount of the water in a closed container, and firstly starting the boiler, put the amount on the water of water and close the container. Then start to boil it. After boiling process take place, remove it out and lift in cold places. In cold place. طيب الobservations بتاعتنا يا شباب ايه هي؟ Firstly, you will find the rate of evaporation will be increased. The amount of the vapor that saturate the container is increasing. In first case, the rate of evaporation is high. In second case, the rate of condensation is increased. Condensation represented by the green light. This condensation. And the red color, evaporations. But to make it clear, since in the start of the cooling process, there is no evaporations. Same container removed and put this bottle flask, round bottom flask, in a cool place. You will find the condensation taking place. Okay, you will find the condensation process taking place. Condensation. But this is for evaporation. This is the first case, and this is the second case. Till an equilibrium takes place. Where is the evaporation rate are equal to condensation rate. This case represents the chemical equilibrium. But we talk about the vapor pressures. Vapor pressure. Wait for the moment. Okay. But we are talking about the vapor pressures. It's meant by the vapor pressure. Vapor pressure. Vapor pressure. Vapor pressure represents the pressure of vapor affect the surface of liquid. And this is classified into two states. Vapor pressure of pure solvent and vapor pressure of solution. In case of the pure solvent, we'll find the vapor pressure is high. Since no solute molecule attached to pure solvent. For the same experiment, we bring the closed container and this closed container, put the beaker inside it. This beaker only it contain pure solvent, distilled water. And by boiling process taking place, we'll find all the container are full with the vapor. And we'll find the pressure of the vapor over the liquid surface is very high. But for the same case, for the solution, the vapor pressure of solution is low due to the particles of solute are attached to solvent. Decreases the vapor pressures. For the same container, but in the second case we prepare a solution from it. We'll find the vapor pressure will decrease. Type. Return back to the second property. Vapor pressure it helps us to determine or to predict if the substance in front of us or determine the purity of the substance. If we have a pure solvent, so we'll find it forming the highly vapor pressure inside the closed container. But in the case of the solutions, we'll find the amount of the vapor will be decreased. Elevation and boiling point. Second property. Bismillah. Insert. Bismillah. Rahim. We insert more than one slide since we will need it to complete the session. Here. Elevation in the boiling point. If we compare, so the graph between the pure solvent solution or solvent, amount of solvent in 100 gram amount of solute dissolves in 100 gram. of water. This line represents the normal atmospheric pressure. We'll find firstly 100 degree. 100 degree, it represents the temperature at which the pure water are boil at it. So the pure water, it will boil when it reach the edge of the atmospheric pressure. The pressure of the vapor, it will be equal the normal atmospheric pressure at 100 degree. But for the case of the solution, we'll find the solution may be boil at the TB. TB, it is the temperature higher than what? Higher than the measured boiling point of the pure solvent. So 100 degree represent the boiling point of pure solvent, but TB represent boiling point of solution. Return back to the vapor pressures. For the vapor pressure, we'll find the vapor pressure of solvent or for the solutions, this is represented the vapor pressure. Vapor pressure for the solutions is lower than the vapor pressure of the pure solvent. We'll find the vapor pressure of pure solvent is high. And for solution is low. Which causes that the boiling point of pure solvent is lower than the boiling point of the boiling point of the pure solvent is lower than the boiling point of solution. So if we compare between the solution and the pure liquid or pure solvent, we'll find the vapor pressure of pure solvent higher than the vapor pressure of solution. But boiling point of pure solvent less than the boiling point of solution. This is for the second property. Return back to the third property. Third property is to, so we'll find elevation in the boiling point. Elevation in the boiling point of what? Of the solutions. كل ما بتكون السولوشنز بارتكل مكلبشه في السولفنت بتاعتي كل ما البويلنج بوينت is increase. طيب To determine who is higher in the boiling point. To determine which is higher in boiling point. Firstly, we must determine the identity of the salt. يبقى firstly determine the identity of salt. Ionic or covalent. In case of the ionic, higher in number of ions moles is higher in boiling point. While in the covalent, higher in molar mass is higher in boiling point. An example of when I have two salts like the calcium phosphate and sodium chloride. Who is higher in boiling point? Firstly, return back to the number of moles of ions which you produce from each one. In the case of the calcium phosphate, we will find 3 moles from calcium ions and 1 mole from phosphate ions. So the total number of the moles of ions are 4 moles of ions. But in the case of the sodium chloride, we'll find the 1 mole of the sodium ion and 1 mole of the chlorine ions are produced in the aqueous solutions. So 2 moles of ions. According to this, calcium phosphate is higher in boiling point. Since it produces 4 moles of ions in aqueous solution. Type. Second idea for the covalent compound, who is higher in boiling point? Urea or glucose sugar? Return back to the structure formula of each one. For the urea, NH2 C double bond O NH2 NH2. For glucose sugar CHO CH OH all 4 CH2 OH. We'll find return back to the molar mass since they are covalent compounds. Nitrogen equal 14, carbon equal 12, oxygen equal 16, hydrogen equal 1. For the molar mass, we'll find 12 for the carbon atoms, 16 for the oxygen atoms. We have an 2 nitrogen atoms, يبقى 2 multiply 14, and we have an 4 multiply 1 for the hydrogen. Represented the molar mass gram per mole. But for the glucose sugars, we'll find C6 H12O6 6 multiply 12 plus 12 multiply 1 plus 6 multiply 16. I need to calculate the molar mass for H1. Start to calculate the molar mass. So the molar mass of the first one, it will be Bismillah. Let's calculate it. Bismillah.
180.
It equal what?
180 يا مستر.
108 for the urea. What about the molar mass of the glucose sugar?
لا الجلوكوز شوجر هو ال 180.
So the glucose sugar is 108. But for the urea?
180 مش 108.
180. Okay. But for the urea?
60.
60. So the higher in boiling point, it will be glucose sugar. Why? Glucose sugar is the higher in the boiling point. Higher in boiling point. ليه glucose sugar بقى higher in boiling point? Since it's higher in molar mass. Okay. Return back to the freezing point. The third property. And next session, inshallah, we are going to talk about the osmotic pressure and to solve the problem on this learning outcome. Boiling point elevations, freezing point depression. If we return back to the curve of solubility, why I determined the solubility? This curve represented the solubility in the 100 gram of the water. So this curve represents solubility in 100 gram of water. Why 100 gram of the water? Since the saturated solution from any substance can form it in the 100 gram of the solvent. It's represented the water. طيب نبدأ نتكلم كده على depression in the freezing point. Depression and freezing point. Solubility in 100 gram of water. Return back to the face curve. We'll find this represent 100 gram or 100 degrees Celsius. This represent the normal atmospheric pressure. And this represent the TB. And we'll find the another one represent 0 degrees Celsius is the freezing point of the biosolvent. And the other represented the TF. Bismillah. This represents the case. So in this case, we'll find the gaseous formed, and this face represents the liquid. This represents the solid, liquid, and gaseous. I will bring it drawing. I prefer, so I must stop the chair to bring it drawing. Bismillah. Face curve. Okay. We'll find this is the shape represent the face curve. The correct one will find the vapor in this area, and the solid it will be in the higher area, and the liquid in the middle. So it's not correct, so we'll correct it. So Bismillah. We'll find the solid and the gaseous and liquid. Okay. We'll find the depression in the freezing point for this curve. It causes the formations or transfer the substance from the state to another. To measure the freezing point, the measured freezing point, Bismillah. The measuring TF to calculate the TF equal the number of moles of ions times negative 1.86. It is a constant number. So if I told you when I have the sodium chloride, expected freezing point it will be 2 moles, since the sodium giving to us 1 mole of the sodium and 1 mole of the chlorine, times negative 1.86. It will be by degrees Celsius. As an applications for the freezing point, we will find in the cold countries the spirit application in freezing point. In cold countries, spread salt in the two sides of fruits to lowering the freezing point of solution causes the formation of ice take a long period of time. لما بيرموا شكاير الملح على two sides of the root بيبدأ the salt is forming the salty solution. فلما يكون salty solutions يبقى الفريزنج بوينت يحصل لها depressions. اشمعنى؟ لو انا قارنت الفريزنج بوينت للسولفنت freezing point of solvent higher than the freezing point of solution. يعني كل ما انا اكون solutions freezing point يحصل لها lowering more for the solutions. يعني لو expected the water is freeze at 100 or at 0 degree, the solution it will freezes at lower degree. Okay. طيب inshallah this is the part for the first part from the learning outcome 11. When taking this learning outcome in the two sessions, inshallah next sessions will finish it to solve talking about the osmotic pressure and solving difficult questions in the Zomdal test bank. Not anyone leave before taking the attendance. check the attendance. بسم الله الرحمن الرحيم. Okay, see you soon إن شاء الله next session. السلام عليكم ورحمة الله وبركاته.
I'm good. She